Hi, Jeff Tung from the National Weather Service Forecast Office. We have a question that came in on Twitter about the GFS and the Euro. And when we're talking about models, we have lots of models that are run around the world that simulate the atmosphere. The global forecast system is known as the US model. That's our global model. And the European Center for Medium Range Forecasting is known as the European model. But it's not just one model. The European model really consists of over 50 runs. There's the main run, which is known as the operational run, and then there's 50 deviations that are run. So we're really looking at a whole spectrum of model solutions. Here in the United States, the Global Forecast System, the GFS, the operational run that we look at and you look at, there's 21 versions of that, actually 20 versions of that. And then we look at the Canadian model. There's 20 versions of that. And that all goes together in a North American ensemble forecast system. So it's not just one run that we look at. There's multiple runs of these models. And little differences in the initialization of the model. Little difference in the wind field over the Pacific Ocean can mean the difference for us 3-4 days down the line of a coastal blizzard or high pressure. So there's a lot of uncertainty that gets included that we look at in these models. So you can't just say that the European has this and the GFS has that. What we look at is the variability within those systems. We look at ensemble means, we look at that, but there's also the spread and how uncertain the solution may be. So you can't just say that the European is the king, the GFS is secondary. Again, there's a lot of different runs of these models that you have to look at. Next question comes from Michael in Brooklyn. He's asking about why do thunderstorms weaken when they reach New York City and Long Island? And that's a great question, Michael, and something that we've observed here for decades in the National Weather Service. And there's a good reason for that. When we have convection, it comes from the west to the east with the westerly winds that blow across the United States. So that's what we'd expect. And you see those thunderstorms over Pennsylvania, and they come across New Jersey, and then they hit New York City and Long Island. And typically they really weaken. And that's the case climatologically, that they do weaken. And the reason is they start to ingest marine air, the air that comes in off the ocean. So to the thunderstorm, that marine air is cooler, it's denser, so it's like trying to pull lead up into the thunderstorm. And the thunderstorms just don't have the energy to lift that moist, cooler air from the marine layer up into it. So once it hits that marine layer, it's like, that's it. I can't lift you anymore, and I'm going to dissipate. So that's what we observe. A lot of times we have these squall lines coming through, and they'll weaken as they get to New York City, start to ingest the marine air, come across Long Island, and commonly dissipate. So great question, Michael. Thanks for asking. We got a question in from Janet, and she's asking about the negatively tilted systems that we get here along the East Coast. What does that mean when we get a negatively tilted system? Well, when we talk about negatively tilted, we're talking about the position of the upper air trough, the jet stream position and the orientation. Normally that's a positive slope to the system. In other words, it's leaning forward. When it becomes negatively tilted, it starts to lean backwards and slows down. So when we have our nor'easters and we have a negatively tilting system, we're looking for a long and prolonged period of stormy weather, because these troughs in the jet stream are what produce our surface storms.